Alright, so what we will do today is we will again pick up some problems that I had posted yesterday before the class, the ones that we did not do or that we could not do rather, and then we'll try solving it, and I would request you all to participate and see if you are comfortable solving those problems or not, and then we'll go to the next chapter, which is unit conversions. So again, these units are enrolled rate, ratio, rates and proportions. These are known to you guys. We are not learning anything new. However, we are looking at the kind of problems that you guys will face related to this topic and how prepared are we, or is our approach powerful enough for solving those problems or not. So starting with ratio, proportion and rates problems. So just doing a quick roll call. Who is missing? Okay, so Sarah joined. So we have quite a few of you. Some are still missing. I know Ria will not be joining today. She had informed me. So that should be fine. Alright, so let's start. So same approach like we do always. We read the question a couple of times and then see what is this talking about. So this question is one of the questions that I sent yesterday. I'm just reading it loud for you guys. The rate of perceived exertion, RPE, okay, scale runs from 0 to 20 the rate of perceived exertion, RPE, scale runs from 0 to 20 and is approximately proportional to a person's heart rate. If the RP rank of 20 corresponds to a person's maximum heart rate of 205 beats per minute, what RP rank corresponds to the person's resting heart rate of 70 BPM? Round to the nearest integer. Again, sounds very cryptic. Let's read it one more time. The question is the rate of perceived exertion, RPE. I'll just keep noting down some of the things because I don't trust my memory. So rate of perceived exertion, RPE. This is a cryptic term that we came across. The rate of perceived exertion scale runs from 0 to 20. So the scale runs from 0 to 20 and is approximately proportional to a person's heart rate. So this RPE is directly proportional to or approximately proportional to a person's heart rate. If an RPE rank of 20 corresponds to a person's maximum heart rate of 205, 20 corresponds to maximum heart rate of 20 beats per minute, another term, BPM. What RP rank corresponds to person's resting heart rate of 70 BPM? So this is the resting heart rate, 70 BPM, 70 beats per minute. Okay. So now we have read this question 2 times, one last time, and then I'll let you guys solve it. The rate of perceived exertion, RPE, scale runs from 0 to 20. If an RP rank of 20 corresponds to a person's maximum heart rate of 20 BP, 205 BPM, or 205 beats per minute, what RP rank corresponds to a person's resting heart rate of 70 BPM? Round to the nearest integer. So the question is what RPE? You have to find out the RP for 70 BPM. And I'm assuming that this question is not as difficult as it looked in the first go after reading it 3-4 times. I want you guys to solve it for me and let me know if anybody is facing any problem. I'm assuming everybody could hear the question clearly. Let me know if that is not the case.
Yeah, I heard it.
Okay. Lorian. So the kids who joined late, I'm just reading it one last time at a slow pace, and this is an opportunity for everybody else to just follow it. The rate of perceived exertion, RPE, scale runs from 0 to 20 and is approximately proportional to a person's heart rate. If an RP of 205 beats per minute or BPM corresponds to, if an RP of rank 20 corresponds to a person's maximum heart rate of 205 BPM, what RP rank corresponds to person's resting heart rate of 70 BPM? And find the value in the nearest possible integer. Let's see how you guys are solving it. And I'm assuming everybody is solving it, right? At least one yes?
Yes, sir.
Okay.
No. Yes, sir.
Somebody said no? Okay. So you guys have 2 minutes, okay? I'm not going to give you guys a lot of time so that no, we can save some time for the next topic that we want to pick up. And it is actually a 2-minute problem only. Neil, Zara, Nikhil, everybody trying? Deep?
Yes, sir.
Okay. Yeah.
Is it, was it like round up to the nearest integer?
Yep, it was.
So is it 6?
I mean, you can give me an answer. I will verify it.
Yeah, I think it's 6.
Okay. I'm sorry? You got 7? Okay. So Deep, for whatever reason, your voice is coming very low. Your audio is very low. So I heard it 7, but see if there is something that you can do to fix the audio. Yes, Chris.
So I got 6.8, so like running it off to like 7 basically.
Okay, 2 votes for 7. Okay.
Am I still coming low?
I'm sorry?
Okay. I was asking if I was still coming low. Let me try to think.
Yeah, it is kind of low for me at least. Sunarka, Savya, anywhere close to being done? You got 7. Okay. So I got 3-4 answers. Can I assume that everybody tried? I mean, some of you are maybe angry with me, that's why, or upset with me, that's why I'm not telling the answer, but I'm assuming everybody tried, right? Okay.
Yes, sir.
Okay. Alright. Don't be upset with the teacher, okay? Alright. Coming back to this one. So, let's hear Dhanvin's approach. Just tell me the approach, Dhanvin. What did you do?
I used the butterfly method.
Mm-hmm.
So first I multiplied 70 with 20.
Okay.
And I got 1,400. And I divided 1,400 with 205.
Okay.
And I got 5.6, but rounding that up, I got 6.
Okay. How about Deep?
Yeah, low. Is it still low?
Yes. I will let Chris explain this for me. As per me.
I think.
So, Smarni, we are trying to solve a problem. Again, we are continuing from where we had left yesterday. So, this was a problem which was saying that RP is a scale used for measuring the heartbeat, the scale given is 0 to 20, and where 20 corresponds to the heartbeat or beats per minute for the maximum heart rate. We are trying to find out what will be the scale for a resting heartbeat of 70 BPM. I mean, the question was not as simple as I stated. It was like a verbose question, a lot of information to it, but we had just extracted that. So, Chris, do you want to explain what was your approach?
Yeah, so sure. So what basically I did was that since we know that we have an RPE of 20 and BPM of 205, I just divided 205 by 20, and then I got 10.25. And since I know that we're dividing from like BPM over RPE, so then I took the 70 BPM and then divided that by 10.25, and then I got like 6.8, rounding it to 7.
Okay. Yeah. Alright. So, Pradeep, did you do the same thing? Kind of. Okay. Now, I have a different approach, and I will keep on repeating. I mean, I don't have a different approach. It's the same thing, but the way I'm projecting it is a little different. So, remember yesterday we were discussing, right? When we're talking about any problem, right? You have to put that like a story, and you have to we have to write it like, okay, if I have some value, this is the value. If this changes to something, what is the value? And for finding something else, what will be my value? So here, what is known to us, I mean, whatever we have to find out, it has to be on the right hand side, always. Now, what we have to find out is scale. What is the scale for this BPM? Meaning, I have to put the scale on this side. So my story has to be like, okay, I know that scale of 20 is for 205 BPM, and I have to find out the scale only for this BPM. That means I will start with this. When my heart rate is 205 or my BPM is 205, my scale is 20. Now, what I have to do is, I have to find out for 70 what will be my scale. This is what I'm trying to find out. In between, there will be one step. I'm trying to break it down into the simplest possible form. I have some value that is known, and again I have to find out another value for the same parameter. I have some value known, but this is what I have to derive. In between there is one step, and that one step is for unit value. So for 205 BPM, my scale is 20. What will be my scale for BPM of 1? It will be 20 divided by 205, right? Like 5 banana cost you $20. 1 banana will cost you 20 by 5. Correct? Same thing here. So 205 BPM corresponds to 20, scale of 20 for RPE. So 1 BPM will be equivalent to this much scale. 70 will be equal to 70 times of the value for 1, which is 20 by 205. Done. Do the calculation, you'll find it out. Now here you can find all the fun elements, right? So you'll say fine, it's 70, we'll do tic-tac-toe. I love playing, so I'll play 40 into 5. 20 I can break into 5 into 4. And then I have 205, which is 5 into 41. So this 5 and this 5 gone. Then I have 20 into 14. Now I cannot break it further. So 20 into 14 is 280 by 41. 41. I will just round it to 40, just to make it my life easier. I can do one more tic-tac-toe. It's approximately 7. So yeah, 7 was the right answer. So what I'm saying is, on these problems with ratio, proportion, rates, see if you are able to see. It's like a tit for tat. The examiner who is giving you a question is giving you a big story. You have to convert that story into a smaller story. Okay, fine. This is what you told me. Okay, scale 20 is for 205 BPM. You are asking me to find out what is the scale for 70 BPM. Okay, so I'm just putting your story in your words. 205 BPM corresponds to a scale of 20. 1 BPM would correspond to 20 by 205. So 70 will be whatever is the value of 1 multiplied by 70. That's it. Very simple, straightforward approach. I'm not denying what you guys did was wrong. I'm saying, see if you find this one simpler. Make sense?
Yes, sir.
Everybody with me? Neil, Sarah, Sunarka, Smrni, Sravya, everybody? What happened to Sravya? Sravya got really upset with me? Okay, alright. Sravya will be back. I hope everybody is following me, right? Does it sound okay? Okay, alright. Now let's pick up another problem. This time I will try to keep my mouth shut as much as I can. But I will still read the question. No doubt about that. So let's look at the next question. The force that friction exerts on a car is proportional to its mass. The force that friction exerts on a car is proportional to its mass. Now we know that whenever there is any movement, there is a friction, right? When you are moving forward, there is a friction which is trying to pull you back. So if you are not pressing the gas pedal, car will gradually stop. So taking that concept in mind, the force that friction exerts on a car is proportional to its mass, meaning more the mass, more the friction. Suppose friction exerts 6272 newtons. 6272 newtons. This is a unit of force. Suppose friction exerts this many newtons of force on a 1600 kilogram car on a wet road. On a wet road. I'm just reading the question, writing it down. The way I will do it, that's what I'm doing here. I'm just writing on your behalf. How many newtons of force would friction exert on a 24 kilogram car under the same condition? So condition remains the same. So one last time, I'm reading it for you guys. The force that friction exerts on a car is proportional to its mass. Suppose friction exerts 6272 newtons of force on a 1600 kilogram car on a wet road. How many newtons of force would friction exert on a 2400 kilogram car under the same condition? So, time for me to go quiet. Everybody heard the question, right?
What if we have a decimal? And do we just round it up to the nearest?
It's okay. See, I'm not really concerned about you guys getting 5.8 versus 5.7 versus 6.1. Okay. I'm more interested in knowing what is the approach that you're taking. Okay.
Yeah, I think I got 612.
You got 612. 612 what?
Newtons?
612 newtons. Okay.
I don't know. I feel like it's wrong. I think I'll do over the question once more.
Yes. Yeah. That's my recommendation to all my kids. Okay. If you are doing things faster, it's a good news. Two ways. One is, yes, you have finished it. Second is, it gives you a little more time to review. Never shy away from review of your own work. Okay. We are never perfect. At least I'm not. And I wish you guys are much more perfect than me, but then there is no harm in reviewing, because that improves your chances of being right. Aryan, are you able to get the question?
No, sir, I'm kind of confused.
Okay. Now I'm just at least checking that did you get the question? It says, I'm just reading it for you, okay? I mean, I'm not reading, I'm just saying it for you. the amount of force applied by friction on any object is proportional to its mass. Mass is like the weight we talk about, right? So it says if 6,272 newtons of force is applied on a car which is 600 kilograms on a wet road, what will be the amount of frictional force applied on a car which is 2400 kilograms in mass under the same condition?
Yeah, I think I have a different answer now.
Yes, it has to be different.
9,408.
Say that again.
9,408.
Okay. Yes, Chris.
Yeah, I just finished as well, and I did get 9,408.
Same thing for you, Brent. Okay. Aryan, is the question at least clear to you now?
Yes, sir.
Okay. Are you able to try?
I'm trying right now, sir.
Yeah, please. Yeah. Okay. How about you, Dhanushri?
It's sir.
Okay. How about you, Dev? Dev, don't tell me you're upset with me. Not talking to me. Okay. Then Deep, are you able to try?
Yeah, I'm trying.
Okay.
I also got 9,408.
Wonderful. Your answer came loud and clear, and your voice as well.
Me, right?
Yep.
Okay, perfect.
This time it was better. I mean, no, but again, you went low again. It came loud and clear all of a sudden, then again went down.
I saw, like, I opened the thing, and, like, it just, look, it's just going down.
Yeah, it's okay. Yeah, Nikhil.
I got 9,408 as well.
Okay. So, I got few answers, and I'm sure everybody is pretty close to being done. Just in the interest of time, I will just quickly check it for everybody. Sarah, Neil, are you able to try it out?
Yes, sir.
Okay.
Yeah.
Okay. So here's the thing. I don't know whether I'll be successful as a maths teacher or not, but I will make you guys learn one thing, that is converting your math problem into a story. And if you guys learn the art of telling a good story or making a good story out of the math problem, at least you will enjoy for sure. Perfection will come with practice, but the enjoyment is guaranteed. So everybody gave the answer 9408, and I'm sure whoever is doing it, most of you will get the same answers. But how? Again, same story. Remember the 6 circles I was talking about? Here, this side I will have all known things. Here the given value, here the value for unit, and here for whatever we are trying to find out. This side you have 2 things, one thing known, this thing you will derive, and this thing also you will derive. Now look at this. Let's fit in this 6 circle situation. Now the question says this is the force applied on a mass of 600 kilograms. We have to find out how much is force applied for this mass under the same condition. Good that the condition is same. If that under the same condition part would have been omitted from the question, I would have been totally confused. Because here it says on a wet road, here it doesn't say that. Is it okay to assume that road is wet? If the road is not wet, probably the friction will be different. We all know, right? When it rains, the car starts skidding, meaning friction reduces, right? So good that the condition is there. And again, these are trivial details, but they are very, very important. Trust me, one small word in your word problem could create a big mystery with respect to your answer. Okay, so coming back to this one. So this much force is applied on this mass. what is the force applied on this mass? Meaning I have to derive the force. Meaning force cannot be on the left hand side, it has to be on the right hand side. So let's see what is known first. So we are told that this much force is applied on this mass and have to find out for this mass. Meaning force has to be here. So this is what is known to us. This much Newton of force for 1600 kilogram mass. Okay. So this part is known. Now I have to find out for what is the force applied for a mass of 1 kilogram, 1 unit. Okay, so for 1 unit, yes, whatever I am getting for 1600, this will be divided by 1600 to get the force for 1 kilogram mass. Once I got the value for 1 kilogram mass, then whatever you ask me, I can do it. If you ask me for 5 billion, I can find it out. I know the value for 1 unit, right? It's as simple as that. If you know that one pair of shoes will cost you $60, how much you have to pay for 20 pair of shoes? You know, okay, 1 unit multiplied by 20. If you know one pair of shoes costs you $60, if I have to find out the cost of 500 pairs, I know we never buy this many pairs, but I'm saying for the sake of mathematics, if you do that, you just multiply by 500. So ultimately it boils down to finding out the unit price, or unit cost, or unit value. So here we got the value for the unit, meaning for 1 kilogram. Now we have to answer for this 2400 kilogram. Whatever value I have for 1, I'll just multiply that by 2400. And another thing, I'm sure you guys will be knowing it, but to simplify your calculation, right? If you have zeros at the end, you can knock them off. 2 zeros here, you can knock off 2 zeros, like a regular tic-tac-toe that we do. Now, here 62, 72 into 24. 24 I can write as 8 into 3. And 16 I can write as 8 into 2. One more tic-tac-toe. I have 62, 72 into 3. 62, 72 I can break it into 31, 3, 6 into 3 into 2. So these two became 62, 72 and I have a 2 below. This and this gets knocked off. I have this value, multiplying that probably gives you the same value that you guys were giving me. Okay. Net, same thing. Did we do anything new? Did I teach you guys anything new? Answer is no, absolute no. We are just looking at the revenge situation. The examiner gave us a question by writing a story. We are writing our own story, interpreting that story actually. Whatever was told to us, we said just put that in that structure. Say, okay, whatever is to be known has to be on the right hand side. So first situation, this is what is known. I am putting this way, and whatever is to be derived has to be on the right hand side. So I have to derive the force, I'll put that force in this side and then I'll state my story. 600 kilogram, this Newton, 1 kilogram, this Newton, 2400 kilogram, apply this much force. Done deal. No complexity, no confusion. As long as again, this is also like memorizing things. I'm not saying that you have to memorize this approach. What I'm saying is, you just test the story in a way that on the right on the right hand side you have to derive, this side is no, kind of thing. Okay. As long as you follow that pattern of stitching your story, the chances of you being right is more. Any questions? No? Ask some questions.
No, sir.
No? Okay. Everybody clear? Danvin, Deep, Dev, Dhanushri, Sarah,
Yes,
Neil?
sir.
Okay. Alright. Smarni, clear beta?
Yes, sir.
Sunarka, no problem?
No, sir.
Okay, wonderful. Alright, so let's move on. So now we want to, so these are some of the sample problems, right? I mean, again, is it all? Probably not. Now it's left for you guys to do some more practice. Randomly keep on finding problems, search for different problems on the similar topic, be it on Khan Academy, be it on Excel sheet, be it on no, not Excel sheet, worksheet, or wherever you find different problems, try solving them out of curiosity. Don't stress yourself out saying, okay, I have to solve 500 problems. No, I'm saying that look for different opportunities to figure out, is there any other problem that I'm not able to solve with whatever I know? Or among your friends, say, okay, fine, let me find one of my friends, say, okay, fine, this one I have solved, I think I have mastered it. Can you make me go wrong with one problem? Give me one difficult problem. Let's see. Do that in a more playful way. That's what my message is. Okay, and then we'll see if there is something that we get stuck with. That's a good news. That okay, fine. Whatever we learned, there is some more opportunity for us to learn. Okay. Otherwise, I have no clue. I don't think even if I spend 3 more hours, if I'll be able to teach anything new to you guys with respect to ratio, proportion, and rates. Yeah. Is that okay? All right. So let's go to the next one. That is called unit conversion. Now, you'll say, sir, you are wasting time, like you always do. So, yeah, wasting time. I enjoy that. So, what do we mean by unit conversion? I mean, what is the role of unit in our life? I mean, let's get a little philosophical here. Well, if somebody says, okay, let's solve few problems on unit conversion, what would it mean to you? How would you explain that to me, who is a 5-year-old toddler right now? Anybody? Explain that to me. I'm a baby right now. What do you mean by unit? I mean, why do we need unit in fact? Yes, Nikhil.
A unit is to measure something and to see how big it is or how small, like the amount of something.
Okay. It's more like a scale. Yeah, go ahead.
Unit can, as you said, scale. It can measure length, volume, weight, time. It's just how you apply it that really matters.
Right. I mean, a very practical example would be, let's say, if I talk about how tall I am. I'm not very tall. I'm just average height. But still, if I say, I'm okay, I'm not very tall, I'm not very short, I'm okay height. Doesn't mean anything. If I say, I'm 5'6", it still doesn't make any sense. What 5'6"? Right? I know you guys have something in your mind already, that's why you're relating it, 5'6", I know what exactly this old man is talking about. But then, still, for somebody who is not conversant with this unit thing, would continue thinking, what exactly 5'6"? Then based on your knowledge and understanding, you'll say, okay, 5'6". Oh, maybe he's talking about 5 feet 6 inches. How about 5 kilometers and 6 meters? Can that be my height? No. Can I measure distance from my house to, let's say, Dave's house? Dave lives in Chicago, I'm in Dallas. In meters. I mean, if I'm saying distance between my house and Dave's house in meters, I'm essentially talking about how do I take a scale which is 1 meter and measure from here to Dave's place. I might end up spending my whole life doing that, right? What if I get even more crazy and say, okay, I will measure distance between my house and, let's say, Deep's house using centimeters. So now we're talking about something that you can relate to. That okay, there are different ways to measure different units. If I'm talking about measuring height or distance, I'm talking about certain units. Will I use the same unit for measuring how much gas I have to fill in my car? Probably not. Will I use the same unit for measuring how heavy I am? Probably not, right? You guys are much lighter than my weight. I have put on a lot more weight with age. But then, how to measure that? Is it just saying enough that, okay, I'm very heavy? Probably not. That is not the way math exists, right? So, in summary, units are nothing but the scales used for measuring different things. Now, essentially there are 4 types of things that we measure. And again, it has nothing to do with math. Forget about it. Forget about math for a little bit. Let's take, I'm not getting personal here. Let's take Sunarka as an example. If I have to talk about Sunarka, what are things I can talk about? How tall he is, what is his height, what is his weight, yeah. Then how much space he needs, how big a small chair he would need for sitting on it, or how big the room has to be. Can he fit in a cage for a parrot? Probably not. He needs space, right? All of us do need space, depending on how big or small is the volume of our body. So basically we are talking about weight, length or height and the volume. So now again, sorry, but I didn't mean to point you by any means. I was just giving an example, okay? I could have given my example too. So height, weight and volume. There are 3 things. Height, we can relate that with length also. I mean, you make me lie on the floor, that becomes my length. If I'm standing straight, then it becomes my height, right? And then there's one more thing that we measure against, time. So these are 4 key things, key entities, objects, things, whatever you call it, that we end up measuring. Weight, volume, length and time. So I had my own way of measuring things, Pranit has his own way of measuring things, Sunarka had his own way of measuring things, Aryan had a different thought in mind, Smarni had a completely different idea. I'm just making up. So everybody had different ways to measure things in the ancient times. Okay, though we never existed in those times, but there were people who were trying to formulate things, and they all came up with their own ways of measuring these 4 things. Okay, and that is what gave birth to 2 systems. One is called the metric system, and one is called US Customary system. So a very simple analogy here is, everything that you see in India, you go to India, to meet your extended family there, you will see that they weigh anything in kilograms. They measure distance in kilometers. They measure volume in liter. They talk about time in minutes, hours, second. Here, come to US, as soon as you took the flight, landed here, everything changed. There is no kilometer, you're talking in miles. There is no kilogram, you're talking in pounds. Right? There is no liter, you're talking gallons. So these are 2 different systems that we end up dealing with. So summary is, this metric system is used everywhere in the world except for North America. North America and a little bit of Canada also. North America includes Canada anyways. Little bit of China also uses this. Okay, I had the first-hand experience of being in China, so that's why I'm relating it. So now you will say, how do we differentiate? Simple example here. In metric system, let's say if you are measuring small distances, you talk about centimeter, millimeter, meter, kilometer. Here it becomes inches. Okay, and there is a relationship among them also. So we'll learn a little bit of that as part of unit conversion, but we are just trying to make sure that we recollect all the things that we know about the units, and then we'll come to the conversion part of it, which will be fairly straightforward. So here, this might be a little underrated for you guys, at least from a concept point of view. When you look at the problems, that is when we'll deal with the word problems, which will give a different flavor to this understanding. But let's make sure that our building blocks are strong. Okay, so we'll come to that. Let's see who all remembers one song. 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 One song which I had told in one of the previous classes. I'm sure many of you were not there in that class, but the whole metric system revolves around one song. That song is milli, centi, deci, meter, deca, hecto, kilometer. Millicenti, decimeter, deca, hecto, kilometer. That's one song that takes care of the entire metric system. Now, distance when you are measuring is in meter. Volume when you are measuring, it's in liter. And when you are measuring weight, it's in gram. And here, when you are talking about distance, distance is in meter. So it becomes millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. When you are measuring volume, volume is in liter. So you replace the meter with liter. So this becomes milliliter, centiliter, deciliter, liter, decaliter, hectoliter, kiloliter. When you are measuring weight, weight is in gram. So you replace everything with gram in the end. So milligram, centigram, decigram, gram, decagram, hectogram, kilogram. So millicenti, decimeter, deca, hecto, kilometer. If you remember this song, that's enough for the entire metric system. Now, there is one more relationship. Here, 10 millimeter, I'm just saying in terms of meter, okay? And that applies for all the other entities also. 10 millimeter makes 1 centimeter, 10 centimeter makes 1 decimeter, 10 decimeter makes 1 meter, 10 meter makes 1 decameter, 10 decameter makes 1 hectometer, and 10 hectometer makes 1 kilometer. Now, if you have to convert millimeter to meter, how many tens you are talking about? 1, 2, 3. Oops, sorry, what did I do? Millimeter to meter, right? So, yeah, 1, 2, 3. 10 millimeter made 1 centimeter, 10 centimeter made 1 decimeter. So, yeah, multiply 3 times 10. So, you know that, okay, 1000 millimeter is equal to 1 meter. Similarly, meter to kilometers, you see, how many halves you are making? 1, 2, 3. 10 to 10 to 10, 1000. So, 1000 meter makes 1 kilometer. Same thing applies for everything else that we talked about, be it volume, be it weight. You're just replacing meter with liter for volume, meter with gram for weight or mass. Is this sound interesting?
Yes, sir.
Okay. Alright. So, even if it's not interesting, it's the only song that helps you have a good handle of the entire thing. Tomorrow, if somebody says, okay, find out how many millimeters are there in kilometer, you might not remember it. If you remember this song, you'll say, okay, fine, how many halves you're talking about? 1, 2, 3, 4, 5. What did I do? Oh, sorry. Millimeter to kilometer. 1, 2, 3, 4, 5, 6. Right? So, you can count how many halves, right? 1, 2, 3, 4, 5, 6. 6 halves. So, 10 times, 6 times 10. Meaning 10 into 10 into 10 into 10, 6 times. This becomes 1 million. 1 million millimeter gives you 1 kilometer. 1 million milligram gives you 1 kilogram. 1 million milliliter gives you 1 kiloliter. Yeah? And this conversion, you don't have to memorize it. As long as you just memorize one song, depending on what you are dealing with, you can multiply it, you can find it out. Same way, if you are given the value in kilogram, if you are given value in milliliter, let's say, if somebody says, okay, 1000 milliliter equal to how many centiliters? 1000 milliliter equal to how many centiliters? Okay, so here you can go with the same thing approach of what we were doing. You know that you have to find out centiliter, right? You know that 10 milliliter gives you 1 centiliter. Okay? You have to find out 1000 milliliter equal to how many centiliters. So 1 milliliter will be equal to 1 by 10 centiliter. 1000 will be equal to 1000 times of 1. So 1 by 10 into, you actually divided 1000 by 10. So if you are given milliliter, if you convert to centiliter, you are talking about 1/2 in the reverse direction. Basically you are converting a smaller unit to bigger unit, so obviously the count will be less. So that's how you're dividing. And you can stitch the story the way you want, but the basic concept will remain the same. Is this clear? Is everybody clear about whatever we are doing?
Yes, sir.
Okay. Now, so this is within the same metric system. This doesn't bother much. What happens when we go from here to here or vice versa? But this is one house, this is another house. Let's first understand the specification of both the houses, and then we'll figure out what is the correlation between them. Okay. So we'll come to this. So here, metric system was much more amiable. You did not have to worry too much about it because there was one song that was catering to the entire movie. One song, you were just replacing the characters and the entire movie was made. Here that is not the case. So only good news is between the two systems that time measurement happens the same way. Everywhere, be it India, be it China, be it Pakistan, be it US, be it Canada, be it North Korea, South Korea, whichever country comes to your mind. Regardless of whether they are using metric system or customary system, time is the same way. Seconds, minutes, hours, days, weeks, months, years, decades, century, whatever. And 60 seconds, 1 minute, 60 minutes, 1 hour, 24 hours, 1 day, 7 days, 1 week, 31 days or 30 days, 1 month. And that remains the same whether you are talking about metric system or customary system, US customary system. So that way, one problem is taken care, meaning we don't have to worry about the difference between the two systems. But the other three entities, volume, let's start with the easier one, distance, mass, volume. So here there is no kilometer, millimeter, centimeter, decimeter. Here it is inches, foot, yard, mile. Does anybody remember what is the relationship between them? How many inches make 1 foot? 12. Yep, Yannick.
I'm gonna answer.
Yeah, you will have more opportunity. We have interesting things coming out, we don't worry. So how many foot make 1 yard? 3. 3 foot makes 1 yard. How many yards make a mile? 1760. Yep. Now, when we talk about mass or weight, what are the units? Ounce, pound, or lb, and then ton. Now let's see, how many ounce make a pound?
60.
60. How many pound make a ton?
2000.
2000. Wonderful. Okay. Now comes the volume part. So here, as long as you know the relationship among them, whether you have to convert inches to foot or foot to inches, you will be able to figure out. If you are converting foot to inches, you will multiply by 12. If you are converting inches to foot, you will divide by 12. And here, as long as you know the halves, from here to foot 12, 12 to yard is 3. So if you have to convert inches to yard, you will take 12 and 3 both into consideration. Inches to yard, you will divide by 12 into 3. If you convert yard into inches, you will multiply 12 into 3. And again, it's little bit of thinking. Let's say if you have 1,000 yards, will be equal to how many inches? You know that every yard is bigger unit. I'm converting to a small unit, meaning my numbers will kind of explode. It will become bigger. So that happens by multiplying. So even if you don't, if you're starting to figure out whether to multiply or divide, you have to always put your thought, okay, 1 yard itself gives me 12 into 3 inches. 1 yard is 36 inches. So it has to be bigger than this. And the only way it can become bigger is by multiplication. I cannot divide a number to make it bigger. Right? So that will give you a clue, knowing this relationship and which way you are going to go for your calculation. Make sense? So Suhina has joined 7 minutes early. So Suhina, you will hear something that will be little loaded for you, but take it easy, okay? Don't get stressed out. Alright. So this is on the distance and the mass part. Now let's look at the volume side of it. Volume, when I'm saying, I'm talking about the liquid volume. So here it starts with teaspoon, then you have tablespoon, then you have cups, then you have pound. Cup?
This is liquid, right? So
Yeah. I'm just saying.
pound, it's gonna be like
Cups, ounce.
ounce and then cups, right? Is it cups?
Let me recall. Who all remembers? I had sent it to you guys.
Teaspoon, tablespoon,
Spoon, cups, then ounce, then
cups,
then cups,
quarts,
then pint,
pint,
then quart,
and
then
gallon.
gallon. Okay. So it's 3 teaspoons make a tablespoon, 2 tablespoons make an ounce, 2 ounce make a cup. Okay. And then how many cups make a pint? I had sent you guys that conversion also. I also keep on forgetting it. So I'm sorry?
4.
Okay. 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 3 to 8. 3 teaspoons make a tablespoon, 2 tablespoons make an ounce, and 8 ounce make a cup. 2 cups make a pint, 2 pint make a quart, and 4 quart make a gallon. Yeah. So basically, when you're talking about filling gas in your car, these are the units you'll be using. If you ever say that I will put 2 teaspoons of gas in the car, you can imagine how far the car would go. Yeah. Because most of the cars give mileage from 20 to 45, depending on what kind of car you're driving. So if you're putting 2 teaspoons of gas in the car, be ready to push it soon. Yeah. So again, these are the conversions that you guys will have to, I would not say memorize, because interestingly here in the question they give you the conversion also. But then it's better if you guys are a little comfortable with them. At least you know the sequence. It will be easy for you to relate and solve it by yourself. Okay. So we will probably stop here, because this is just the building block for us to make sure that we understand what are the different systems, what is their role, and I'm sure you guys were knowing about it before. We just did a recap of that, and then in the next class we'll do some practice problems to actually deal with the kind of problems that you will come across in your city exams and all, and see how prepared are you for that. Yeah. And most of the topics which are easier in nature, the problems that you will deal with will be more of a word problem, where they will try to get you jumbled up with a lot of sentences in it. You just have to decode to find out the message from it so that you can solve it. Alright? So with that being said, I will let you guys go. Enjoy the rest of your evening unless you have a question for me and you want to help me hostage.
Hi.
I use a very strong word, hostage. Now nobody is going to keep me hostage, but yeah. Alright. We'll upload the video of the class in a little bit. Whoever missed the class, they can watch it later. Anybody who wants to do a recap of what we did, they can always use the video. Alright? See you guys on next Saturday. Alright, bye bye. Bye bye. Yeah. Bye bye.